So data classification, data can be either a raw data or a classified data. Raw data is, as data is collected, it is a raw data in original form. If you classify the data, then you can draw a visual inference from the data easily as compared to raw data. Classified data is more informative. So data classification, the types of data classification depend on the data types. So we go one by one of different data types. First, we consider numerical data, which is discrete. So data is discrete, it has no fractions, and it is a numerical data. So first scenario is that there are less variety in possible values. So if these are the observations, these are the values, and the variety is from 0 to 6. So variety is less. So in such a situation, you can easily classify the data in this form as the first value, a type of value or variety, first variety, that is 0, there are 10 observations. For 1, there are 40 observations. So the second column is frequency and the first column is observations. The first column is are the values and the second column is frequency. This should be very clear to students that second column is frequency. The value, which is 2, is observed 80 times in your study. So frequency is 80. So this kind of classification table is possible when variety is less. The second scenario is when you have a discrete data and there is lot of variety in values. For discrete data, we can make class intervals of values. These are class intervals, and this type of class interval is known as inclusive class interval because the lower limit of class interval as well as upper limit of class interval is, is included uh, in the class interval. Uh, for example, in first class interval 11 to 20, if there is observation with value 11, it is included in first class interval. And if there is a value of 20, it is also included in first class interval. If there is observation of 21, then it is included in second class interval. And it should be very clear that it is a discrete data. So there is no value between 20 and 21 because it is discrete. There is no value in between. So this is about discrete data class intervals, and this is a type of inclusive class interval. Then we have a numerical data which is continuous. For continuous numerical data, we can make class intervals like, for example, in this example, I have taken first class interval as from 100 to 110. There are 10 observations. Second column is always a frequency. The first column is of observations. The second class interval is 110 to 120. In this situation, in first class interval, the observations are from 100 to 109.999. Any observation of 110 will be included in second class interval. It will not be included in first class interval. So you exclude the upper limit of the class interval in this situation. Hence, it is known as exclusive type of class interval. In this example, I have shown you that the first class interval is from 10 to 20, the second is from 20 to 30. So the first class interval include observations from 10 to 19.999. If there is observation of 20, it is included in second class interval. So the fractions are possible in this type of class interval, that is exclusive class intervals. So this was about classification of the numerical data. Now we go to classification of the categorical data. Categorical data include attributes. As I told you in my previous lecture, a variable is usually used for a continuous data and sorry, for numerical data, and attribute is used for categorical data. So for categorical data, for example, if attribute is gender, so gender can have two possibilities, males and females. And the second column is frequency. So there are 25 males in this study and 36 females in this study. So this is a classification of categorical data. It is very simple. You just write down the options of the attribute or categories, and in front of those options, you write the frequency. And of course, you can calculate the proportions as the frequency divided by the total number of cases. So total number of cases is sum of all the frequencies, and you divide 25 by 61. This will be proportion of males in this study. Then 36 divided by 61 is proportion of females in this study. So this is how you can classify a categorical data. Then there is a special situation when there are two attributes. So each individual uh, in your study have the both the attributes. So, for example, there are two attributes. One is smoking, the other is lung cancer. Each observation will have one of the option of smoking, whether the individual will smoke or not smoke. So there are two options for smoking, yes and no. It is here column wise, and similarly lung cancer may be present or absent. So there are these two attributes which are associated with each of the observation. So you can classify them on the basis of these two attributes simultaneously. So it will make a contingency table or a cross tabulation when in a special case, when there are only two options for each attribute, then there will be two rows and two columns, and this is known as 2 by 2 table. So this is a cross tabulation or a 2 by 2 table. This is required especially for the assessment of association between the two attributes. As I told you in one of my lecture, that whether smoking is associated with lung cancer, we can easily apply chi-square test. And to apply chi-square test, we need to make the contingency table or a cross tabulation of these two attributes. One of the attribute is smoking, the other attribute is lung cancer. And there are two options of each attribute, so it is a 2 by 2 table. So this is all about data classification, which depend on the type of data.